Hi everyone, RJ Steiner here. I want to run through my proposal of having a Node.js based BeLL that will tackle a couple of issues. Um, Firstly, the security lockdown of the API, um, which will then need a new app update mechanism, which will then allow us to consolidate other node processes into this project, like the resource optimizer, and then thinking about after we get the initial security lockdown of the API of whether or not you're logged in or an admin, possibly creating a role-based permission system similar to Drupal, how their role-based permission works. So all of this is based, the initial architecture, I looked through a lot of different potentials for doing this, and the best example that I could find that was both simple and secure and elegant was this example here that I found, which is an example app of using Angular, which is a Backbone JS alternative. So they built the server-side stuff for this Angular app, and which could just as well be used for a Backbone app. And the big difference here is it allows you to define API endpoints and also a login system. Passport is the login mechanism library or node module that this utilizes. It's it's the most popular login mechanism for Node.js. Um, and, uh, and so it's interesting to look through what they have here. You'll see that my proposed app.js file is set up very similarly, with just a few exceptions. So let's take a look at the code. Let's start with my pull request. So here's my pull request, pull number 37 in the Open Learning Exchange BeLL Apps repository. If we look at let's start with the commits. Just a couple of commits. First thing I did was move the databases folder that had all of the design documents to a folder called API. You'll see why that it was in a second. And also move the app folder that had all the HTML and JavaScript to a folder called public. Public is just a convention for where you put things that are accessible via the server. It could just as well be named app, but going with a public convention seems to make sense to me. And then the really interesting one where I add the app file that ties everything together, and I adjust the resources database file to have an authentication logic to dictate who should be allowed to access what operations on the resources database or the resources route. Then I fixed some stuff, made an error, and then I incorporated some code to update the code base, which is influenced from another project that I worked on called Fido. Had to do a similar thing. So let's dive in. We're going to look at files changed in this pull request. And let's go to, there's lots of these files just moved. We can sort of just ignore that and just look at the ones where the code is changed. So let's start with resources.js. In API resources.js, this file, there is, you'll recognize this, the design doc. I renamed the variable ddoc to endpoint because this is actually going to describe everything about this API endpoint. It's going to describe what queries can be run and also the authentication logic. And so this has like a very simple function that called an auth function that you feed in the request and a response and a next callback. And so what this does is it just checks the request object that's handed, runs the is authenticated. If it's not authenticated, then it sends to the response a 401, which is denied in HTTP language. Otherwise, it just runs the next. So this is a very simple example. We could do things. So the app file is going to use this auth function to check when it receives a request, an HTTP request, to say like, okay, this is being we're getting a request to the resources database. Run this function, and essentially, like, if this function doesn't authorize it, it sends back a 401. Otherwise, it actually completes the request. This is the most basic example. We could do things. So this is just like essentially like two different roles. Either you're authenticated or you're not. It doesn't check if you're like an admin or whatever. So as soon as you're authenticated, you pretty much would have any permission to do puts, posts, deletes, and reads, or rather gets in HTTP talk. And yeah, so it's a very, very basic example. And it, it still has the endpoint views and yada and so on and so forth. All right, so skipping to app.js, this is where it gets interesting. At the top of the file, we include things like the Express framework, which allows us to define routes that the server is going to get hit with and what to do about that. It imports the Passport library, which is for session management. And then we create a strategy, a Passport strategy, to be able to define how a user is authenticated. In these first few lines here, we define how the strategy works. Let me skip ahead just a little bit to look at the route where, when you authenticate, this that local strategy is actually used. So right here. So when there is a post to the server at /login, it runs this Passport authenticate using the local strategy, and that's all you need to do. So because of this, if there's a post including a username and password, it will run this strategy. And if it is successful, running this logic, then Passport takes care of adding a cookie to the browser and logging the session and a whole bunch of other stuff. But anyways, let's dive into this Passport strategy. So this is actually, as they say, a stupid example, where it just checks, gets fed in a username and password into this function and a done callback. So it just looks at the username. If the username is admin and the password is admin, then it returns done with a user object where the username is admin. Otherwise, it returns done with the second parameter being false and this message that this is an incorrect username or password or whatever. So this is just a super, as they say, stupid example, but it wouldn't take that many lines of code to actually do run a member lookup on the members database and see if that username and password match anything that's found in the members database. If anything is found in that members database, then we would return done, null, and then the name of the user, as opposed to just returning admin. Skipping back down to these other session management stuff. So I have these session routes section. So there's that login one, and then there is this logout. And so this will actually, because we're using Passport, it adds this logout function to request. And so that'll destroy the cookie in the user's browser and then just send back a normal response of like, okay. And so that's handy. There's also this helper function, or this helper callback. So like if you're in the app and you just hit like /logged in, it'll return like a true or false. So that's, in just a couple lines of code, we now have session management. But now let's actually put that to good use and look at the API endpoints. And so I declare this one route at /API star, so catch all, anything requested at API /anything, this route will catch. And it looks at the first parameter in the path. So let's say it's the API/resources, and it gets the requires in from the API folder API/resources.js, and so when that's required in, then that auth function that is in our resources file, in our resources endpoint file, will be available. And so we feed in the request and the response object and a callback. And so this gets called, and then let's go to, I'm just going to skip over because it's kind of awkward to scroll up and down over there. Essentially, that means that this function will get run. And so you see the request object and the response object getting sent in. The response object is being fed in case there's like this 401 that needs to be sent back. And otherwise, it just runs the next object, which is this function right here. So if the else qualifies, the next function is run. The next function is this function. This function is just a simple piping of the request from the request URL. So it builds a URL to the CouchDB, so the local host 5984, the CouchDB that's local on the machine. And then it adds the rest of the request URL. Actually, what we would want to do is shave off this API part, but essentially saying like building this URL to, so if it was like request documents, or let's say the URL that is being requested is API/resources/ABC. So the document ABC in the resources database. It would pipe that request URL to using the request library, and it just essentially like this is like a proxy. This just like pipes everything through, and so anything that's returned from that endpoint is just going to get piped back to the browser. And so right now this is just an example for gets. This doesn't cover deletes, puts, or posts. But if we just essentially do this almost the same thing 3 more times with a little of extra magic, this could be working for all of those operations. So we would have, then we would have essentially for each of the endpoints in the API folder, we would have an auth function. And so for each of these, API endpoints, we can customize our auth function. Because, like for example, maybe we want everybody to be able to edit resources, but we don't want everybody to edit everyone's member profiles. So for the auth function for members, we would check to make sure that the person requesting the edit would also be the same person who is editing it, or maybe they're an admin. We would have additional logic in the auth function for members, and that would be the case for each of these different data types. We'll want to just start defining, wait, who can do what on each of these databases, and our auth functions are how we would do that. So so that pretty much covers the security aspect of my proposal. Some other niceties are, let's see. So I show on line 43 of app.js. There is this this line here. Pretty much says like anything else that it doesn't match any of the endpoints here. These routes that are declared. Look for it in the public directory. And so this is where our my app is. So we'd be able to, like, let's say the application was on a Raspberry Pi that was at BeLL.local on the local network. Then you'd be able to, and it was binded, and this app was binded to port 80. You'd be able to type in BeLL local myapp/index.html instead of the really long URL that we're usually using. Even better would be is if we put an index in this public folder that maybe lists a bunch of URLs of various applications that are on the server, and my app would be, the BeLL My App would be one of them. Right now, the BeLL My App is pretty much the only one that we're going to be forwarding to people, so maybe we just make that that be an index with a JavaScript redirect to myapp/index.html. So there we would be able to get nice short URLs. This also, I don't mention it here, but this is also an added performance gain. As I found out over the summer, when you have a CouchDB document with thousands of attachments, or any number of attachments, the lookups of those file attachments, every time you request a file, the more files there are, the longer it takes, because it has to look through all those file names and be like, okay, here it is, and deliver it. CouchDB is not. It turns out CouchDB documents are not very performant at doing that. And so this kind of bypasses having to have a file system mounted in CouchDB, so we don't have to deal with that. We don't have to deal with that limitation. We kind of solve that by caching the entire application in the user's browser using browser-side caching, but this would still speed things up. So, anyways, so now if we no longer have the BeLL apps in the CouchDB, then our replicating of the BeLL apps application is no longer going to work. You can't just replicate a new version of the application into the database because the code is actually living on the file system level. So I've worked in some other projects, particularly a project called Fido, that is also similar in that sense, that the application code is not in CouchDB. So you need some kind of mechanism to be able to tell users, hey, there's updates available, and listen for when the user requests to run those updates. And so I've got two more routes that I've put in here into the app.js file. One route, if you send a GET request to get available updates, it will run this code, get available updates, which is inside of, it's included from lib. We'll run this code, and it will figure out, okay, these are the updates that have been run in the history JSON file, and these are the updates that are available in updates JSON. It'll find the difference between those two and return a JSON object saying, okay, you've got like 5 updates to run, or you've got 0 updates to run. So on the client side, you can have a mechanism that is constantly checking get available updates, and when there's available updates, displaying a message to the user that there are available updates. When they see that, after they review the available updates, they then send a GET request to run available updates, which then sequentially goes recursively through the available updates, doing them one by one. And that's the extent of that. There are some changes. So the way that I did it in the Fido project, like I said, there's this like updates JSON file, which is describes all the updates available, and there's this history JSON file which describes the updates that it's run. I'm proposing a new way of doing that, particularly instead of having history JSON and updates JSON, just getting rid of those altogether, and instead replacing history JSON with an actual number in the package JSON file. So we should be able to determine how many updates. If we know what updates there are, then we should be able to look at the current version number and determine, according to this version, what updates need to be run. We know what updates there are available to be run by looking in a directory, like for example, oops. So we have a folder called updates that has all these update files in it. Now, the package JSON file is determined, the update version is determined by, essentially a git pull or a git merge. And so this updates folder actually can't be the same repository as the one that it's sitting in. Otherwise, there's this sort of logical problem where there's not going to be the updates unless the underlying code is actually updated. And so the idea is to have two different Git repositories. Have the updates repository be its own repository that we're running a process that's constantly doing a Git pull, and then we're able to update the updates constantly, and then cautiously update the have it user controlled when the parent repository, the BeLL apps repository, is updated. An example to look at. Let's see, I put a link to it somewhere. 1 second. So I note I added to git ignore the updates folder. And I say this could be a local location of a Git repository of update scripts. See Fido updater scripts for examples. So these are what the updater scripts look like. And they just run commands, and when they're done, they run a callback. And the updater code actually listens for each of these callbacks to see when they're done. So you're not running updates in parallel. The updater's code is actually saying, like, okay, this one finished, all right, I'll run the next one. This one finished, all right, I'll run the next one, and so on and so forth. All right, and so if we look at the Fido server account, there's the Fido repository, and then there's the Fido update repository. So on each of our Fido devices, which are Raspberry Pis, they have the Fido repository and they have the Fido updater repository. And the device is constantly saying to pull from Fido updater, and just on every 5 minutes or so. And meanwhile, the Fido this repository on the device only gets updated or changed when you actually have a script running from the Fido updater. So you can see, like, in this scripts directory, there's probably this one didn't involve a code change, it just did some other updates. So these update scripts can be really flexible. I mean, they could be doing all sorts of things. This one actually, this was like reconfiguring some origins. I was changing the name of the remote updater server, and but this is a really important line. So what this does is it CDs into root Fido, into that Fido repository. It fetches from Fido server. It fetches all the tags, and then it checks out the specific tag for the release. All right, so that just about sums up my proposal. One other thing. This also gives us the opportunity to consolidate a lot of potentially our other repositories. The Node.js processes, in particular, the resource optimizer, could be incorporated into this project now because we'll have Node.js running. So we could incorporate it into the app.js file. And then there might be some other repositories that we want to incorporate as well. So that means in one BeLL install, we have all the pieces that we need in order for it to be running. All right, that's all now. I'll take questions later. Feel free to look through the code and make proposals and add comments and whatever you'd like. I'm looking forward to discussing it further. Bye now.